Hello everyone, welcome to the International Conference on Mathematics and Science Education 2021. I want to say thank you for watching my presentation. An honor to meet you all. My name is Fachri from the Mathematics Education Study Program Graduate School at the Universitas Pendidikan Indonesia, Bandung. And I am the author of this paper. This paper is entitled Effects of Blended Learning on Students' Mathematical Problem-Solving Skills, a Meta-Analysis. So, let's get started on the first part about the background of this paper. In today's 21st century, rapid development occurs in technology, information, and communication, known as ICT. This rapid development has an impact also in the world of education. One of the impacts of ICT development is changing the strategy of the education system from the traditional face-to-face mode to an independent mode based on digital technology, online, that can be done anywhere and anytime. This strategy also used during the current COVID-19 pandemic. One of the learning models that match this strategy is the blended learning model. Mathematics learning in 21st century emphasizes to students how important it is to develop problem-solving skills. Problem-solving skills are essential to be investigated because they have relationships in transferring the learning process. In order to solve the low level of students' mathematical problem-solving skills, researchers and mathematics teachers collaborated to apply blended learning. Many studies were conducted by researchers in Indonesia on the effect of blended learning implementation on students' mathematical problem-solving skills. However, several studies reported inconsistency regarding the effect of blended learning on students' mathematical problem-solving skill. Some studies agree that blended learning is more effective in improving students' mathematical problem-solving skills than the conventional learning, while other studies state the opposite findings. On the other hand, education policymakers need accurate and precise description and information on what aspect or condition to implement blended learning to improve students' mathematical problem-solving skills. Moreover, using primary studies alone cannot obtain such information. So, we need a method that can answer this inconsistency problem. Several questions regarding the effectiveness of the blended learning model on students' mathematical problem-solving skills can be answered by meta-analysis. In the methods section, the study uses a systematic review method with meta-analysis as quantitative technique. Furthermore, regarding the inclusion criteria, we formulated them based on the PICOS framework, which contain first, population. All article on mathematics education at educational level, students in junior high schools, senior high schools, vocational high schools, and university in Indonesia. Second, intervention is a blended learning model. Third, comparator is conventional learning model. Fourth, outcome, mathematical problem-solving skills. Fifth, study design is experimental and quasi-experimental. Following study publication ranks from 2014 until 2021, and then the primary study reported in our statistical data. On literature strategy, studies are collected from various databases such as Google Scholar, Garuda Portal, etc. Furthermore, we conduct study selection through 4 stages, namely identification, screening, eligibility, and included. And finally, we did the statistical analysis using CMA software. Statistical analysis was carried out, and the first is to calculate the effect size. Second, analyze publication bias. Third, interpret the effect size of each study based on the classification. Fourth, investigating heterogeneity in the meta-analysis. And fifth, justifying the significant improvement of students' mathematical problem-solving skills by the implementation of blended learning. All right, now we turn to the result and discussion section regarding the findings we got in this research. First, in the result of literature search and data extraction, through searching the database based on keywords that have been set, through the 4 stage of study selection mentioned in the method section before, 11 primary studies were obtained that met the inclusion criteria and were involved in the meta-analysis study process. Next, about publication bias and sensitivity. You see in the figure 1, the image is a funnel plot. You can see the picture. Figure 1 shows that distribution of effect size from 11 primary studies in this meta-analysis was symmetric around both sides of the vertical line, and the effect size studies were very close to the central region of gravity. These findings indicate that the effect size of the studies included no publication bias. Since most interpretation of the funnel plot are subjective, the horizontal FSN value will also be examined in determining the publication bias. This result of horizontal FSN in Table 1 show that 494 studies with zero effect size are needed, so that the study effect size are not statistically significant. In other words, there need to be at least 494 studies whose findings contradict each other, so that data from the 11 primary studies included are considered invalid. Based on the calculation, you can see in this slide, the result is 7.6 greater than 1. The result of this calculation indicate that the study included in this meta-analysis study resistant to the publication bias. Furthermore, the meta-analysis study sensitivity by conducting a heterogeneity test, and the results are shown in Table 2 in the two meta-analysis model. Table 2 shows that the homogeneity value of the studies in meta-analysis is calculated as Q is 34.536. The critical value of the chi-square table at 95% confidence level is 18.307, with degree of freedom is 10. This finding indicates that the Q value is higher than the critical value in chi-square. So it can be stated that the analyzed studies show heterogeneous distribution. It is also seen at a value of P less than 0.05. Then each hypothesis studies effect size homogeneity needs to be rejected. Therefore, a random effect model was chosen with an average effect size value of 1.075 with a standard error of 0.149. The effect size is being positive and reflecting the moderate effect. Consequently, it can be stated that blended learning has a moderately positive effect on students' mathematical problem-solving skills. In the results, in Table 3 shown the overall effect size of each primary studies. In the results shown in Table 3, referring to the classification, it can be checked that the 8 effect size have significant positive effect. 1 effect size had moderate effect, and 2 effect size had small effect. Because the random effect model was chosen to be used, we then carry out further analysis by calculating summary effect based on the characteristic of the study. The results are shown in Table 4. This research determined 5 study characteristics, namely study year, educational level, sample size, research method, and sampling technique. 11 studies in this meta-analysis are grouped into 5 characteristics of the study. You can see it in Table 4. All study characteristics in each group analyzed to have a high effect size. These findings mean that the implementation of blended learning on the students' mathematical problem-solving skills is very effective. Based on the result of the null hypothesis, the p-value for each group on the study characteristic is less than 0.05 unless the sample size group is less than equal to 30. The p-value is more than or equal to 0.05. The value is 0.051. This finding means that the blended learning has significant effect on students' mathematical problem-solving skills in each study characteristic group. Based on the results and discussion, we can conclude that the overall effect size based on the random effect model is 1.075, which indicates that the implementation of blended learning on students' mathematical problem-solving skill has a greater positive effect than the conventional model. Second, based on the educational level, this research reveals significant difference in the implementation of blended learning on students' mathematical problem-solving skills. Therefore, this meta-analysis study provides information to education policymakers, namely mathematics teachers or lecturers, that implementing blended learning as an alternative learning is effective in solving a problem related to the low students' mathematical problem-solving skills. It should be noted that the study has limitation. The study has limitation on study characteristic and the number of primary studies. Therefore, for further meta-analysis studies related to the application of blended learning to students' mathematical problem-solving skill, it is necessary to increase the number of primary studies. So that is all my presentation. Thank you very much for your great attention. May all those we have shared be beneficial for all of us.